So we're gonna start on page 8, lesson 2, on uncertainty. What comes into mind when somebody says uncertain? What does that mean, uncertain? Not sure, right? Not sure. So how does that play into our measurement? So let's say when you have a measurement from, let's say, from 15 to 16, right? So this is, let's say, a measuring device, and I kind of zoomed in 15 and 16. This area here become, and let's say we have a measure. This is our pencil, for example, our pencil, and it lands over here. Now we know it's going to be between 15 and 16, but there's a level of uncertainty because we cannot say for a certain, 100% certainty, what the measurement of the pencil. I'll go pencil here. All right. So we know it's going to be between 15 and 16. We could somehow say it's about 15 and a half because we can gauge it, right? We can gauge it's about 15 and a half, right? But it's not quite 15, but it's not 16, but we can say it's about 15 and a half. So there's a level of uncertainty when it comes to the measurement in between the precision. So let's just read it. When you use a measurement tool, it is difficult to measure something, anything, exactly. Okay? For example, you cannot measure the exact length of a pencil with a ruler. You might get close, but depending on the precision of the ruler, remember, precision are how fine the tick marks are, right? Those are the how fine the tick marks are on a ruler. But are we exactly correct? Okay, so that's a question. Are we really exactly correct? Every measurement has a degree of uncertainty on it. So what does uncertainty mean? So this is probably something that we need to write down on our formula sheet or our cheat sheet or a study sheet. Uncertainty is defined as half of the precision of our measuring device. So once we figure out the precision, that means how fine are the measurement in our measuring device, we can figure out the half of that, which is the uncertainty. So this means that you cannot determine the uncertainty before we determine the precision. So here's a formula. So let's put a box around that. I'm going to put that on our formula sheet. Okay, now let's take a look at example 1. Determine the precision and uncertainty of each of the following measuring tools. This is an airplane gauge. Okay, so I don't know how, I've never seen something like this before, right? But this is an airplane gauge. So gauging the air-fuel ratio. I don't know what that is, but let's just see. So to figure out the precision, start off with precision. We need to do the measurement. This is not is equals to measurement divided by number of tick marks. So number of tick marks. So let's do that. let's do a measurement. Okay, well, if we measure from 10 to 12, let's just measure. Okay, so let's measure from 12, from 10 to 12. I said 10 to 12. 10 to 12. So what's the measurement there? From 10 to 12, so that's going to be 2, right? 2 air per fuel ratio. Divided by, how many tick marks are in here? So I'm counting from 10 to 12, right? Not counting the first one because that's our 0 mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then there are 10 tick marks. Where did the 2 come from? If we took the measurement from 10 to 12, yeah, so just to take the measurement, so that makes it 2. Is that okay? That's a good question. Maybe, sorry, I didn't explain it very well there. So 10 to 12, that's 2 to whatever units, air per fuel ratio, divided by 10 tick marks. So we counted the 10 tick marks there. Okay, so what's 2 divided by 10? So 2/10. That's 0.2. 0.2. So that means every tick mark is 0.2. Yes, here, come. Means every tick mark is 0.2 air per fuel ratio. Okay, 0.2. And does that make sense? 0.2. So let's just count. Let's just count. So if this is 10, 10.2, 10.4, 10.6, 10.8, 11, 11.2, 11.4, 11.6, 11.8, 12. 12. Yeah, so that was correct. Okay, so 0.2 for each one. Air per fuel. So that's the precision. Now, what's the uncertainty? Now that we have the precision, we can calculate the uncertainty. Okay. Now we can calculate the uncertainty. And how can we calculate the uncertainty? So uncertainty is equals to precision divided by 2. So half. You just take that half. So precision, we got 0.2 divided by 2. So that's going to give us 0.1. 0.1.
What page are you on?
Page 8. Page 8, yeah. Air per fuel. Hi, Seth. Did you get this on Thursday? Yeah. Okay. Was that good? Yeah? So if you missed that one, I could get back to this one after we're finished. Okay, so you can write as much as you can, and then we could always go back because there's going to be more examples later on. Okay. Move to the next one. Okay, well, we're familiar with this one, stopwatch, right? So the measurement there is measured in seconds, the time on the stopwatch. Okay, let's see. Let's first figure out the precision, and then once we have the precision, we can figure out the uncertainty. So first, let's make a measurement. So let's make a measurement. So if you take a measurement between 30 seconds to 40 seconds, okay, so what's that measurement? From 30 to 40, how many seconds is that? So from 30, from here to 40 seconds. So that gives us 10 seconds, right? So if we measure from 30 seconds to 40 seconds, that's 10 seconds. Okay, now from 30 to 40, how many tick marks are there? So how many tick marks? We're gonna count the tick marks, but not the very first one. Okay. Now, can you see? I'm gonna zoom this in very. How many kinds of tick marks do you see in here? We got the big tick marks, right? Yes. Got the big one, right? On the 5, 10, 15, 20, 25, 30. So those are the big ones. What other tick marks do you see? You probably can see the finer tick marks. There's one right there. And then another one. And another one right there. Can you see another even finer tick mark? Can you see another finer tick mark? Yeah, so in between, right? So now it's right there. Those are even finer. Now this one here, it's somehow it got really tiny right there. But this is the biggest tick mark right there at 30. 35, 40, and then there's a next finer, that's this one, 31, 32, 33, 34, 35, right? There's a finer tick mark. And then even finer would be in between, right there, one. Kind of looks like a dot from this angle, so that's why it kind of looks like that. But those are also in between tick marks, and then you can see it's right, maybe just the way it's angled in. So how many tick marks are there? Finer tick marks, the finest one. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You're going to go to the very finest tick marks. So there would be, what did I say, 20? Finest tick marks. can't see that, sorry. So 10 divided by 20, so that gives us 0.5 seconds. So that means this watch, this stopwatch, can read up to 0.5 seconds. So if you take a look at this one, this is our 0. I don't know if you can see that, but this is a 0. This is 1 second, but that's not the finest one. It's actually 0.5 seconds. It's the finest. Okay, so that's our precision. So I'm going to put P for precision. Now we're going to do the uncertainty. Uncertainty is equal to precision divided by 2. Okay, so that's in the formula. So precision, that becomes the point where we are, if it's hovering between the middle, then we are just not sure exactly what that is. So precision is 0.5 divided by 2. So uncertainty is 0.25 seconds. So uncertainty is 0.25 seconds. Is that okay? So I like this because we are kind of reviewing what precision is, and then from there we can determine the uncertainty. Okay, let's do the letter C. Okay, let's do the precision. Precision. Okay, we have to first measure. Okay, let's make a measurement. So nobody had asked, like, can we measure any way we measure, or does it have to be, if let's say one student measured from 1 to 20 and figure out the precision from there, would it be the same if another student does 30 to 70? Okay, are we going to get the same number in terms of precision? Is that okay? So how about let's try it? Okay, let's say student number 1. Let's say student number 1 make a measure. Let's do student 1 measurement from 0 centimeter to 30 centimeter. So what's a measurement there from 0 to 30? 30, yeah, 30. Okay, now we're gonna divide it by how many tick marks. So how many tick marks are there from 0 to 30? Not counting the first one though. So let's see how many tick marks. 1, 2, 3, 4, 5, 6. So 6. So 30 divided by 6 will give us 5. So that means 5 centimeter for every tick mark. 5 centimeter for every tick mark. That's the precision. If you look at this one, does that look like 5 centimeter every tick mark? Yeah, because it's counting by 5. So 5, 10, 15, 20. So that's what. Okay, so let's do another student. Student number 2. Let's say student number 2 did measurement from 30 centimeter to 70 centimeter. So from 30 to 70, what measurement is that? How big is that measurement? From 30 to 70. How big is that? So from 30 to 70, that would be 40 centimeters, right? Is that okay for everybody? So that's 40 centimeters. And then now from there we go, okay, well, how many tick marks are there from 30 to 70? Not counting the first one. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 tick marks. So what's the precision? What's 40 divided by 8? That's going to give us 5 centimeters as well. Okay. So that means every tick mark is worth 5 centimeters. So what does that say? Student 1, oh, I forgot to put student number 1. So student number 1 did a measurement from 0 to 30 and figured out the precision from there. And then student number 2 did a slightly different measurement from 30 to 70. You got a 40 centimeter length there. And that counts for 8 tick marks. It's still 5. Okay, so that shows that, you know, as long as you have a measurement and then counted the number of tick marks, we should be good. So now that we have the precision, we can just do the uncertainty. So what's the uncertainty again? Uncertainty is equals to precision divided by 2. Precision divided by 2. So the precision is 5 divided by 2. So that means it's 2.5 centimeters. Okay. So when it comes to the middle, it becomes such an uncertain point or part of the measurement. Okay. That's a place where we're just not sure approximately where it is or how long the device is. Is that okay? Now this one, well, how can we figure out the precision and uncertainty for this one? Well, because we don't have a measuring device, we can't measure, we can't count the number of tick marks, so how can we figure out the measurement? How can we figure out the precision and uncertainty for this one? Okay. So this is how I look at it. So when the number is given to us, it's just a number that's given to us, what we need to do is we just look at the lowest place value. What's the smallest value? What was that? Oh my goodness. Yes. Forgot about that. All these times it's there. Thank you. And you look at, in this case, if we are given just the number, the measurement, I'll just write it down. If we are given just the measurement, okay, the measurement, we don't know what the device looks like, right? We don't know how they measured it. So here's what we're gonna do. If you're just given the measurement, determine the lowest place value And this will give us the precision. Okay, so you look at the place values. Now, you look at that one. What's the smallest place value? What's the smallest place value? The smallest place value is the 4, right? The 4. So the place value is 1. Ones. So if you think about this, if you were to count this, 64, what's the next one? Would be 65, right? What's the next count? So it would be 65. So you'll be counting by ones. So the precision is 1 kilometer. 1 kilometer. Okay. Ones. That's the place value is ones. And once we have the precision, we can determine the uncertainty. Uncertainty is equals to 1 divided by 2, which is 0.5 kilometers. Now, let's take a look at letter B. Okay. What's the smallest place value here? What's the smallest place value? Are you okay if I say like place value? So you talk, you know, like ones, tens, hundreds, thousands, or tenth, hundredth, thousandth. Is that okay? Maybe everyone's very quiet, and I just want to make sure that you're going home and you know what I'm doing here. So if I give you 1, 3, 5, 7.49 92. Okay. You know that this is ones. This one is tens. This one would be hundreds. And then this one would be thousands. Yeah? That's okay? I think that one's not bad. And then when you get to this part, this is going to be in the 10th place. 10th. This one would be 100th. 100th would be 2 decimal places. And then this one would be 1000th. Okay. So that's what I meant by place values. So the smallest place value here is the nearest 100th. That's the smallest place value, is the nearest 100th. So if the next second would be 11.79, right? 11.79. So what's the precision? Precision would be 100th would be 0.01. The precision would be 0.01 seconds. Now let's do the uncertainty. Uncertainty would be 0.01 divided by 2. So it's going to be 0.005 seconds. Is that good? Let's do letter C. What's the smallest place value in here? This one would be the nearest tenth or 1/10. So the precision would be 0.1. 1/10. Is everybody okay with that piece? 0.1. So the next one would be 15.3, right? Because right now it's 15.2. The next one would be 15.3. So you added a 0.1 to the next one. That's centimeters. So that means uncertainty is equals to 0.1 divided by 2. So it would be 0.05 centimeters. 0.05 centimeters. Okay. Now let's put all those together. Have you heard of something like this? Plus minus, have you seen that before? Like somebody gives you a measurement that's not quite exactly the way it is, but then we could probably say like, oh, give or take something, right? So they're giving you some kind of a measurement, but because they're not sure, they kind of give you some kind of a degree of uncertainty. Well, plus or minus something. So let's see here. The weather person says the temperature is 38.5 degrees Celsius. Oh, I wish. 35.8 degrees Celsius. I wish it's like that, but it's probably minus in this case. Determine the uncertainty of this measurement and then write it in a form. So they're already kind of telling us, oh, this is what the temperature is outside, but it might not be exactly like that. It might be a little bit, give or take something. So from this measurement, what's the precision? So the precision, okay, so the smallest place value is 0.1. 0.1. So the next one is a 0.1, right? So 35.9. So that's a 0.1 of a difference. Now from there, well, what's the uncertainty? Uncertainty is precision, which is 0.1 divided by 2, which is 0.05. That's our uncertainty. So now let's put it together. The measurement, let's go back to this one. The measurement is 35.8 plus or minus, give or take the uncertainty, which is 0.05 degrees Celsius. So the temperature outside would be 35.8 plus or minus 0.05. Is that okay?
Was that plus or?
Yeah, it's plus or minus. plus and the minus at the bottom.
You just add those both.
Yeah, you do both. Take a look at the next example. We are told that the height of the tree is 3.72 meters. Okay, 3.72 meters. Good. So that's our measurement. What's our precision here? What's our precision? So you look at the very last one, very last place value. So 3.72. The 2 is the last precision, the last place value. So that's 0.01. So if you count the next one, would be 3.73. So 0.01 meters. So uncertainty is 0.01 meters divided by 2. So if we divide that by 2, it's 0.005 meters. So putting it together, what's the measurement? 3.72 plus or minus, give or take, 0.005 meters. So we're not quite sure. We think it's 3.72, but it could be plus 0.005 or it could be minus 0.005. Okay? So far so good? Not so bad, right? Yeah. Now let's combining uncertainty. Since every measurement has uncertainty, if you add together two measurements, you must also add their uncertainties. So we have uncertainty for one measurement and another uncertainty for the next measurement. So, and then if you combine those two together, then you have more uncertainties, right? More uncertainties. So let's see here. A string that is 10.3 centimeter long is placed beside another string that's 5 centimeter long. Find the total length of both strings, including uncertainty. Okay, now let's start with this one here. 10.3 centimeters. What's the precision? What's the precision here? Okay, here's the lowest place value is 10.3. So the lowest is 0.1. So 0.1 centimeters. Okay. So if they have a ruler, right? This is 10, 10.3, 1, 2, 3. 10.3 is here. Okay, so each one must be 0.1, right? So 10, 10.1, 10.2, 10.3. So each one is a 0.1 of a centimeter. Okay, so that's where that came from. What's the uncertainty? 0.1 divided by 2. That's going to be 0.05 centimeters. Okay, so this measurement has a precision of 0.1 and uncertainty of 0.05. Great. Now let's take a look at this one. A next string is measured 5 centimeter long. So let's say this is 5. From here is 5. What do you think is the next one? What's the precision for this one? Well, if they gave us 5, so that means each one, it has a measurement of a 5, but a precision of 1. Okay. So this is the nearest ones. So precision is 1 centimeter. Let's do the uncertainty. 1 divided by 2, which is 0.5 centimeters. Okay. Let's add them together. So you got the 10.3 and the 5 centimeters. Okay. So if we add those two strings together, it should add up to 15.3 centimeter length, right? So 10.3 and 5, that's going to give us 15.3 centimeter length. But give or take, plus or minus, we have this uncertainty for this measurement. We have 0.5 uncertainty for this measurement. So we're going to combine those uncertainties, so 0.55 centimeters. So we added the measurements, and then we also added the uncertainty. So we added the measurements, and then here we also added the uncertainty or uncertainties. Okay, so far so good. We'll finish up example 6. Let's see if we can. So this one here, you are building a wooden pathway for your garden, and you cut 3 pieces of board. One piece is 2.09 meters, the second piece is 2.1 meters, and then the other piece is 1.99 meters. Determine the total length of all 3 boards, including the uncertainty. So we're gonna do that individually, figure them out individually. Calculator?
Yeah.
Oh, sure. Calculator. Yeah, I'm gonna need a calculator too in a second. It'll be my calculator then. Okay, so let's start with this one. 2.09 meters. What's the precision? Okay, the smallest place value is the nearest hundredth, so that's gonna be 0.01. Okay, so remember, this is 2 decimal places, it's 2 decimal places there. Okay, uncertainty would be 0.01 divided by 2, which is 0.005 meters. So that's for one wooden board. Let's do the other one, 2.1. 2.1 meters. What's the precision? The smallest place value is 1 decimal place, so that's going to be 0.1. 0.1, because it's 1 decimal place, so it's going to be 0.1. Uncertainty is 0.1 divided by 2, which is 0.05 meters. Okay, so far so good. Now I got this one over here, 1.99 meters. Okay, I see 2 decimal places, So the precision would be 0.01. So I got 2 decimal places, so the precision is also 2 decimal places. 2 decimal places, 2 decimal places. Uncertainty would be 0.01 divided by 2, 0.005 meters. Let's put all the measurements together. Once you put all of those measurements, what would it be? So measurements, total measurements, would be 2.09 plus 2.1 plus 1.99. And we're also going to add up the uncertainty. .18 meters, and then total uncertainty would be 0.005 plus 0.05. .06 meters. So if you put them together, measurement, total measurement, and total uncertainty. So let's go 6.18, give or take, plus or minus 0.06 meters. And that's our final answer there. Okay, so there you go. Well, we finished it. I didn't think we'd finish, but we did. Okay, so I'll leave that with you.